Hi, welcome. In this tutorial, we're going to demonstrate how you can use Tracetest to build a distributed system instrumented using OpenTelemetry. OpenTelemetry is the open source standard for systems telemetry, and Tracetest allows you to run tests on top of your existing tracing infrastructure. We will use Go as the language, but the same principles can be applied to any language. Let's get started. We are going to build a basic bookstore that will expose an endpoint that will give us all available books with its corresponding price. So we have nothing. Let's start by creating a directory to hold our project. Now we are going to use the Tracetest server installer to set up a Docker Compose environment that has already the OpenTelemetry collector and all the required infrastructure to run Tracetest, but more importantly to have our application instrumented. So let's run the Tracetest server install command. We're going to use Docker Compose. We want Tracetest to generate an empty Docker Compose for us. I'm going to just accept all the defaults. You can check the documentation for more details. We're not going to be using the demo app because we're going to actually build an app. It's going to be more interesting than the demo. Alright, let's see what happened here. We have an empty Docker Compose and a Tracetest directory with a Docker Compose that has an upsell collector, Postgres internally for Tracetest, and Jaeger. So that's pretty much all we need to instrument our application and run Tracetest. There's just one tiny setting I like to tweak for running locally. It's the timeout settings. This defines how long a test will take to fail for timeout waiting for traces. And since we are developing in developing mode, I like this to fail fast. So let's have retry delay of 500 milliseconds and a total timeout of 10 seconds. This should be more than enough for our case. Okay, we can now start Docker. You can see we are using this long Docker Compose command. It has two Docker Compose files. This is so your application Docker Compose, it's not mixed up with the Tracetest Docker Compose, so it's easier to read and work with. And it started. You should be able to see Tracetest running here. And it is. Okay. Now let's go back to the code and start doing something interesting. Let's start creating our book service. It's gonna be a Go file, so we can just create a main.go package. File. Package main. Let's just start with the print. This is just to see that we can correctly build. Okay, we're using Go 1.19, and let's see if right. This should be ready to go. Let's just test. Nice. Okay, let's start actually building our service. First, we're going to create a basic Gorilla Mux router, because that I really like that package. New router, and we're gonna have a very simple endpoint, just /books and books list handler. I think it's response writer and a request. That's an HTTP request. Okay, now let's do http.handle /router and http.listen-serve. Let's start just running on port 8001, and we'll have string hello. Yeah, this is our very simple static server. Go around. Tiny. Okay, now we can see if this works. Alright, we have a working service. Now let's make it do something more interesting. Actually, let's make it work on Docker first, and you'll see why just in a minute. We're gonna use one Docker file for all services because they are gonna be pretty much the same. Okay, so what we are going to do with this, actually this is for later. Let's see if this is working. Actually, let's go to the terminal and let's restart everything, but with a build flag. This will build our new image and make everything to work in the same network as Tracetest. And you'll see why right in a second. Okay, now it's working. We should be able to still use the same curl command as before, and it's working, but now we can also create a trace test. So let's try that. Books. Service. So our URL, it's gonna be the internal Docker URL, so it's books/books. Sorry, it's actually books : 8001 because that's the port we selected, and that's just a plain get. Right. And we see that the test run, we actually got some headers, the body, and the trace is waiting. So Tracetest runs this first request and then waits for the trace it generated to be ready, so you can then start adding assertions to the trace. Since we are not actually instrumenting yet, we should be seeing it time out after a bit. And yeah, we just have the trigger and nothing below. That's what we are going to build. Okay, so actually let's try to do some test-driven development by using Tracetest, right? So I'll start by creating a new file. It's going to be called books_list.yaml. This is going to be our Tracetest test. List, books list. Let's give it a name. Books list is going to be pretty much the same as before. Actually, let's just get this. I don't want to be writing all this boring definition. Oops. That's it. We have a basic test now. So let's add some assertions. We're going to be using a test-driven development approach. So we're first going to write a test, see how it fails, and then pick the code so that it works, right? So let's start adding specs. The first one is we want to make sure that the trigger, the books endpoint returns a successful status code. So Tracetest holds that information in the trigger span. So we can just call the span with the name Tracetest trigger assertions, and let's see Tracetest.response status equals 200, right? Okay, now let's see if we can actually run Tracetest against this test in Tracetest. First, let's make sure that Tracetest is correct, our CLI is correctly configured, and it is. Okay. So Tracetest test run -t. It's books list so let's wait for the result, what that last flag means. And it's running. We can actually come here and see we have a new thing running, and again it's only the root span, but now we have an assertion that has a typo on it, so it didn't work. Okay, let's run it again. Let's see the current run, and it takes like 10 seconds, and okay, we see it's correctly detecting that we are returning 200 status code, right? Okay. Now, let's write a more interesting test. So let's see it failed, right? Okay, so we want to make sure that we have at least one span for our application, and that will validate that we are actually, instrumenting the application and making our traces available in Jaeger or whatever backend we have selected, Jaeger in this case. So we are going to create a new assertion, and now we're gonna check that we're gonna see if we have at least one span with the name books list. This is gonna be a span that we will create in our application, right? So assertions test.selected spans dot count equals 1. This is gonna be a root, like the root span for our application, so we only want one of those. Let's run the test and see what happens. Takes a few seconds. And we can see it actually failed now. Let's see what happened. Yeah, it expected 1, but it had 0 matching spans. So let's make sure we have that span. So what we need to do for that is to instrument our application and actually start sending traces. And to do that, we're gonna go to the source and just see how we need to do it. Hotel Golang instrumentation. Yeah, it's not a very simple task the first time you do it, so there's a lot of boilerplate code. So it's usually easier to just get started with some example code, right? So we're gonna start by copy pasting this. You should not copy paste, but we are gonna do this. So what's going on here? We need to create a new trace provider, which will in turn allow us to get an available tracer, which is what the application uses to send traces to the backend. And let's tune up this example. We want a default resource with the semcomp. The semcomp is a library. We're going to be using the 1.12 version. You need to use the same in all the code, so otherwise you might get conflicts with different libraries. And for the service name, we're going to use books. Yeah, let's panic because we want to fail. And that's it. For our exporter, we're going to be using a very basic console exporter, so that we can just see in the console what's going on. And okay, this does nothing yet because we need to first, in the main function, we want to get an exporter. Okay, we want to get an exporter and then generate we need to copy all of this code and we'll get to review it in a bit. Okay, so first we create a background context. We use that background to create an exporter, which in this case is just a console exporter. So we are going to see the generated traces right on the console. And then we use this exporter to create a new provider with some configuration. The resource is the hotel name for what's the service about. And it sets up a trace provider with batching and with the given resource. And again, we need to use books here. Actually, let's use an empty string so we get the default exporter, and that's gonna be fine. Okay, let's see if everything is right. Go multi-tidy. Let's download those dependencies. Alright, and let's see if we can run. Yeah, we have an error. OpenTelemetry trace, who's using OpenTelemetry? The auto import doesn't always work as expected. And there we go. Now we should be able to build. Yeah, that's fine. It can't start because the address is already in use. So let's stop this, rebuild, and see what happens. Seems to be ready. Let's run a pull request and see what happened. Nothing happened, which is not really good. No, that's fine. Nothing happened because we didn't do anything. We just instantiated a new tracer, but we didn't do any trace. So let's add a trace. We want the configure now. Traces span equals tracer.start. I guess this is gonna use the tracer we just configured and start a new span. And the span name is gonna be book. What did we want to call it? Books list, right? Okay. And we need to end the span once the function finishes. And this should give us a span. So let's rebuild. Nice. And see if we can see nothing. You cannot see it. Ah, there it is. It takes a bit. So, okay. We have our book list span being generated with no parent, which is fine. That will be relevant later. So, right now we are not sending this trace anywhere, so it's just a fancy log right now. Let's fix that. Let's try to send this trace to the OpenTelemetry collector we already have. So I already have a function for this. Let's call it new exporter. We can use the function later. And it's gonna use the same context as before. Okay, so this sets a timeout of a second before doing anything. It tries to connect to the hotel collector. This is the actual URL, you can see it in the Docker compose from Tracetest. This is the service name for the hotel collector. And 4317 is the default port for the gRPC endpoint for the OTLP protocol in the hotel collector. And it does pretty much the same. It creates an exporter using the configured gRPC connection, and that's it. So now we should, let's see if we can run it. Oh yeah, we need to do almost tidy. Okay, it is working. We should not see anything now because it should be sending the information to Jaeger now, which we also see because the hotel systems are very verbose with their log, but nothing failed, so that's a good sign. So let's see what happens if we run the test again now. So if everything's fine, we should be able to see. Oh no, we should be able to see the traced or newly generated span here, but we're not. So let's take a look in here what's going on. So 166.86. We need to expose this port in the Tracetest Jaeger, right? We need to restart this thing. Alright, but now we need to rerun the test because when we restart, this is an ephemeral. What's going on? service wasn't able to start because it was trying to connect to the gRPC endpoint before it was ready for the OpenTelemetry collector. So a quick fix for now, let's just make the dependency on that, so we can just move forward. There's probably you can probably implement some retry strategy or other strategies that are not dependent, but right now this is fine. Okay, now it's working, and let's see what kind of trace is being generated. We have our book service. Okay, but this book service doesn't have any root span. What Tracetest does, it creates the root span, the Tracetest trigger span, and it generates a trace ID and sends that trace ID to the propagation headers of the request. So then it can go to Jaeger and ask for all the spans for that trace ID that is already known to Tracetest. But in this case, this span that we just generated doesn't have that propagation. So let's add that. What we need to do is to add a propagator configuration to our OpenTelemetry setting, to our trace provider actually. So I have that code here ready to be pasted. And just before we return, we're gonna set the propagation, the text map propagation, which essentially allows us to propagate headers and stuff. I'm not sure if the order is really relevant for this, but just to be sure, I'm gonna keep it as I have it. And that's just one part, because the other part, okay, so how OpenTelemetry works is it has propagators, and this propagator reads from the context, but we need to have a way to type the HTTP request or the Gorilla Moves request, which is actually a HTTP request, to that context. And to that end, we have the OpenTelemetry Gorilla MOOCs instrumentation. It's a contrib library, and it works pretty well, at least for what I've been testing it. And it's really just a middleware. So right after we set up this, we can use this library. This service name is books, but we're already using this books word a few times, so let's just make a constant for this. Let's put it on the very top. Yeah, right before this. This is all code. Let's just delete it. Okay, and now I think there was, yeah, here we're using the same name, and when we get the tracer, let's use the same. Okay, so now we should be able to see everything connected. As you can see, there's a lot of plumbing you need to do at the beginning, and it's kind of tedious to get started. Especially in Go, when you need to remember to go multi-ID every time you add new libraries. Okay, we have successfully started our server. Hopefully, let's do our pull request, and it's still working. And so let's try to run our test again and see what happens this time. Alright, it worked. Let's see how that looks now. Alright, so we have this Tracetest trigger which is the span, the root span generated by Tracetest when it triggers the test, pretty much how the name implies. Then we have this HTTP span. This span is created by the ODL MOOCs, audio instrumentation, and it's the one that hooks everything together, right? It takes the trace ID header from the HTTP request, it injects it into the Go context, and then that Go context is used on the subsequent functions of the request, and that ties everything together. I think this is a good point to do a git commit.